Hi there, this is Henry Wadsworth, and I'm going to tell you about an activity that I came up with called modeling the moon using sinusoidal regression. This is a good activity that you can do to introduce periodic functions such as sine in like an Algebra 2 or pre-calc class. Hopefully the students would already have a background knowledge of transformations of parent functions. But this could also be used in a lower level class to introduce the idea of mathematical modeling, and I think all students would have some sort of appreciation of the fact that they can predict the future using math. The main idea here is we're going to take a look at the moon's phase over the course of a month, make some observations, and then plot them and try to predict where the moon will be, tonight or next week and so forth. So to start out, if you go to Google and just search moon phase calendar, the first option that comes up, click on that, and they immediately default give you the current month's moon calendar. Now, I found that this works best if you go to the prior month, the month right before the one you're currently in, because then you can make observations about that and predict things about the month that you're currently in. So as you see, what we've done here, or what I've done here, is I went back to December 2013, and now we can make observations about this month. So I start by making some pretty easy observations about the moon's illumination. So I start by asking the class, where is the moon, where is 0% of the moon illuminated? On what day? Third day. On what day is about half of the moon illuminated? 50% of the moon illuminated? Maybe the ninth day. What about, where is it a full moon? And then you can have a talk about, somewhere between 15, 16, 17, 18, and 19. Somewhere in there it's a full moon, so maybe settle on 17. And what we do is we take all these values and I end up writing them up on the board. And you'll see that I had the third day correspond with 0% illumination. Ninth day was half percent, not a half percent, 50%. 17th day was 1, that was 100%, and I have all those written down. And then we even go a little bit further and maybe get some more of the arguable ones. On the 7th day, it's around a quarter moon. On the 13th day, it's around a 75% moon. And you can have a good discussion and figure out ways to get those numbers. Then what we want to do is take that data and put it into our calculator. So what I'm first going to do, and I found this works best, is if I take that data and put it in ascending order. For some reason it doesn't work well in the calculator if it's in this jumbled order. So I'm going to take those same numbers and put them in a list. So I'm going to go to Stat and then hit Edit, which is the first option. And then I'm going to type in all those values in ascending order. And you'll notice that's exactly what's there. I have that 1, which is 0.05. I have the 3, which is 0. The 7, which is 0.25, and so forth. Then what we're going to do is actually tell our calculator to plot that. So I go to second y equals and turn on plot 1. Making sure that it's on, and I go to the type, it should default to scatter plot, but I turn it on just to make sure. And then the X list I want to be L1. The Y list I want to be L2, because that's where I typed in my X information and my Y information. X being the day, the month, Y being the percent of illumination. Then what I do is I hit window, because I want to make sure what I'm seeing is what I want to see. So my minimum X value is day 0. My maximum X value is day 31, because we're doing December. My minimum Y value, 0% illumination. My maximum Y value, 100% illumination, so 1. And you'll notice I have the following plot, which is pretty nice. It looks like I go from 0 illumination up to a full illumination and then back down to 0. Now here's the cool part. I'm going to tell my calculator to fit a sine curve to this. So I have to go back to Stat, scroll over 1 to Calc, and then all the way down until you see sine reg, that's sinusoidal regression, and hit Enter. Now what I'm going to say is take the values from L1, so I'm going to hit second and 1, That's the x values, second 1, comma, and the y values, second 2, which is L2. And then I'm also going to say, hey, take all this data and paste it into the y equals window for me. Or not the data, take the equation you're going to come up with and paste it into y equals. So I'm going to do this by hitting vars, which is next to clear, scrolling over 1 to y variables, and that first option is function, hit enter, and y1 is where I want to store it. I could really store it anywhere, but I want to store it in y1. After that, I then hit enter, and it's going to do all the work for me. It's taking the x values from L1, the y values from L2, and storing the equation it comes up with in y1. And take a look at what we have here. We have y equals a sine bx plus c plus d. Now, if this is a more advanced class, we can talk about all the transformations that have been applied, that there's a stretch, there's a left and right, or actually it's a compression, there's a left and right movement, an up and down movement, and you can talk about how those affect a sine curve, how they take a nice curve and, transform it. If this is a lower level class, then you don't need to go into all that discussion. But I do like to write that up on the board, and notice it has already pasted it into y1 for me. And so when I hit graph, I get the original data that I had, my stat plot, but then I also get this new sine curve. Now what I can do is extend the window. So go back and hit window, and now instead of just seeing the x from 0 to 31 days, let's change it and go way higher, see what's going to happen in the future. So type in something else. Our stat plot data is still for the first 31 days, but now our curve goes all the way out to 80. And now what I can do, we can make observations on this, by the way. We can see every time it peaks, there should be a full moon. Every time there's a valley, there should be no moon. And the places in between are different amounts of illumination. Now what I can do is hit trace and scroll along and look at the x and y values at the bottom changing. Different days correspond to different amounts of illumination. And this is really powerful because this is where I have the ability to predict the future. So today is January 3rd. Now using our model, I want to predict how much of the moon will be shown tonight. Since our x values went 0 to 31, the x value that corresponds to January 3rd would be 3 more than 31, or 34. So I type in 34 while I'm still in trace, and it comes up and says 0.02851. That is a 2.85% amount of illumination for the moon this evening. And that's kind of a fun homework assignment to send the kids home with. We use this model, predicted what the moon should look like tonight mathematically. So go home, take a look up at the sky. Is it actually around a 3% amount of illumination? And then, you can extend this as the weeks go by, see how well our model holds up 3 weeks from now, a month from now. Can we accurately predict when the full moon will be, when there will be no moon, and so forth? So there's lots of extensions you could do. Hopefully you got something from this. Try it in your classroom, even if it doesn't go well. It should be fun, and it's a good experience for everybody. Thanks.